Thank you so much for joining this lesson. We shall be discussing Mathematics Paper 1, Section 2. In the recent past, we've been discussing the Section 1s, but today we shall be revising Section 2 in preparation for the KCSE 2025. Those who are new to our program, please remember to subscribe and remember also to share so that you may invite your friends to the best program, Shifting Grades Online School. Now, when you look at our channel, we've already presented the section 1 of this paper. So all these questions have been solved faithfully and in a very decent manner. So take your time and check the solution for every question in the section 1 that you can see around. So we are now going to focus on the section 2 of this paper, which is again a very good paper. And I hope you guys shall reap a lot from our program. Shifting Grades is the home of academics. Section 2, number 17, which is the first question. We are told that on the graph provided, plot the points P, 22, Q, 25, and R, 44. Then after plotting, you join them to form triangle P, Q, R. So looking at the coordinates, we need to identify coordinate 2, 2. Therefore, 2 on the X and 2 on the Y intersect here. That's our P plotted. Then 2, 5. So 2, 5. That's our Q. Then R is 4, 4. So we've identified the 3 coordinates. Then we've to join them now to come up with the triangle. P to Q, then to R. Very easy, you obtain the first mark. Very easy, you obtain the first mark like that. Then we proceed with interpreting the questions. Now in part B, reflect the triangle PQR in the line y plus x equals to 0 and label the triangle P prime, Q prime, R prime. So the first thing that we're going to do here is to come up with a mirror line for the reflection. So how do we come up with a mirror line? Okay, it's not a must you memorize the line where it passes. You can just say that this line y equals to negative x when you take x to the right-hand side. So with a small table of values of x and y, you'll be able to see that if x is 1, for example, then y is the negative of the same value. If x is 2, then negative 2. If x is 3, then y is negative 3. So that's the relation between the coordinates of x and y for this particular mirror line. So we can come up with it. 1, negative 1. Let me show you the coordinates. 1, negative 1. 2, negative 2. 3, negative 3, like that. So that's how the mirror line behaves, and we can plot it. Let me zoom so that you may see everything. So now I produce that line very well. So without the mirror line, you cannot reflect, because a mirror line is what defines a reflection. Then how do we reflect? We join every point to the mirror line perpendicularly. Then we move an equal distance to the other side for us to get the image. For example, if it's P, we connect P, then we move an equal distance to the opposite side. So we connect P to the mirror line. We connect to the mirror line. Then we move an equal distance on the opposite side. And now using your compass, you can mark the distance here now. So that becomes our P prime after reflection. And you do the same for the next coordinate. which is R. So you do the same for R. You do the same for R. I want to join R to the mirror line. Then I proceed. So R also to the mirror line, you find that it follows the same path as Q. Then now an equal distance from the mirror line to where R is, from the mirror line again on the opposite side, R prime shall be there. So R has also been reflected. Then you do the same for Q. You connect Q, then you move to the opposite side. You connect Q and you move to the opposite side. So Q to the mirror line like that. Then you move to the opposite side. And now you can consider now the issue of distance now. From Q to the mirror line, then now from the mirror line, an equal distance, you mark it off on the other side. So this now becomes our Q prime. And with these, now you can connect to come up with the second triangle, which is the reflected of PQR. Very good, two triangles now, already connected. That's what we call reflection. Join points to the mirror line, even if now it will be a different mirror line, a different triangle. Basically, you connect coordinates to the mirror line and you move an equal distance to the opposite side. You move an equal distance to the opposite side. So we have successively reflected. Now look at part C of the same. Triangle P double prime, Q double prime, and R double prime. The image of P prime, Q prime, R prime is given a translation by vector T, which is a 8, 1. You know, a translation is described by a translation vector. Plot the triangle P double prime, Q double prime, and R double prime. Look at that. So let's now check out. When you are given a translation vector, XY generally, you are supposed to move X units along the X-axis and Y units along the Y-axis. So here, it means we are moving 8 units and 1 units downwards. On the X-axis, if the units are positive, we move to the right. On the X-axis, if they are negative, we move to the left. Now, according to the Y-axis, if units are positive, we move upwards. And if they are negative, we move downwards. So that's how we treat the negatives in case the translation vector is having a negative. So for the X, we are moving 8 units. 8 units to the right, then 1 unit upwards. They are both positive. So look at this now. An easy way of identifying. I know there are people who will calculate the coordinates, but that's a lot of work computing coordinates. So you just stand at P, for example, and you move 8 units. So 1, 2, 3, 4, 5, 6, 7, 8, and 1 unit upward, 1. So you'll find yourself at coordinate 6, 1. That is now P prime. You move again for Q. So you move how many units? You move 8 units and 1 unit upwards. So 1, 2, 3, 4, 5, 6, 7, 8, and 1 unit upwards. So you'll find yourself at 3, -1. That's Q double prime. Should be double prime here. Then what about R, which is here? You also move the same 8 units and 1 unit upwards. 1, 2, 3, 4, 5, 6, 7, 8, and 1 unit upwards. So you'll be at 4, -3. That's R double prime. Very simple. So that's how simply we are supposed to translate using a translation vector. Then you connect now. You connect all your triangles now. These are a good question. This is a very good questions. Yes, there we are. There we are. Aha. Let's look at part D. Let's look at part D. We are told that a triangle P triple prime is negative 6, 1. Q triple prime is negative 3, 1. And R triple prime is negative 4, 3. Is the image of the double prime. Describe fully the transformation that maps P double prime to P triple prime. So let's check now. This triangle has to be drawn first, negative 1, 6. So let me come up with this coordinate, negative 6, 1. Negative 6, 1. Negative 6, 1 is here. Sorry. Sorry. Negative 6 on the x. Negative 6, 1. Negative 6, positive 1. Here is the point. So that becomes our P triple. Negative 3, 1. So negative 3, 1 is here. That's our R. Oh, that's Q triple. Then R is negative 4, positive 3. Negative 4, positive 3. Negative 4, positive 3. That's where R triple prime is. So now we can complete that to get the triangle first. Then we proceed to determine we connect P to Q. Then Q to R and also to P. You see? And I hope you guys remember that our consultation line is 07 04 15 33 6. Yeah, 3366. So that's our consultation line. You can reach out as we continue learning together. Okay. Now, the instruction is that we're supposed to determine the transformation responsible of this now. What has mapped this third triangle to the fourth triangle? This is 1. This is 2. What is mapping triangle 3? To 4. The idea here, you're supposed to know first, this is not an enlargement. So the figures are congruent. You can see angles are equal and even sides. It has not been enlarged. So it's not a shear, it's not a stretch. It's not an enlargement. So let's check. Could it be a rotation? Could it be a reflection? Okay. So now we're supposed to join. If it's a Q, we join Q to Q prime. Q to Q prime. Q to the image of Q, yeah. Q to the image of Q, like that. Then after that now, we bisect this line that joins them perpendicularly. We bisect this line perpendicularly. Let me bisect it. Bisect it perpendicularly. Preserve that bisector like that. Do the same for R or for Q, any other. Let's say we do it for Q. So for P, sorry, that was Q already. So for P, I join P and P. I join P to P. Then I also bisect P to P, then I bisect. Now, in case the bisector is the same line, in case the bisector repeats itself, then ladies and gentlemen, it will be a reflection. But if the bisector doesn't repeat itself, if the bisector doesn't repeat itself, then it means you're dealing with something else. Let me check this second line. I can use let me use a different color here. I've also bisected. And from what I can see, that the bisectors are not the same. We have the bisector 1 here, and this is now bisector 2. So they are different bisectors, meaning that what we are dealing with is not a reflection. So for reflection, that's an X. We are not dealing with reflection. So we proceed to examine whether this one is a rotation. What do? We check when we connect. You see the two lines are meeting at a point, and that's the origin. So now we can say that if a point, for instance, if a point is connected, for instance, point P, then now we move to the opposite side. We connect it to the center, then we move to the opposite side. What angle has been involved there? Let's check. If we connect P to P prime and we move to the opposite side, we connect P to the center, that is, we connect P to the center. Then now from center to the P prime, then we measure the angle. We discover it's 180. Again, we can check for maybe a coordinate like R. If we connect R to the center and we move, so R to the center, then we move to R prime, you discover it's behaving the same. The line is just proceeding to the other side. This is an indication that this is a rotation. Center 0, 0. And the angle is positive 180 degrees. It can also be a rotation. It can be a rotation. Center, still 0, 0. And the angle, negative 180. Negative 180. That is still the same thing. A rotation through 180 is the same as a rotation through negative 180. And again, something that you're supposed to note is that this is the same as an enlargement. This could still be an enlargement. Then, with an enlargement now, we talk about center and scale factor. Center 0, 0, and scale factor negative 1. With a scale factor of negative 1, you just connect a coordinate to the center and you move an equal distance on the opposite side. So there is no difference between enlarging with a scale factor of negative 1 and also rotating through positive and negative 180. As long as the center is maintained, that transformation is the same. So all those transformations can fit as the answer, but you don't have to write the 3 of them. Just give us one. So that is it. We check the last part of the same question. We are still in number 17, ladies and gentlemen. Identify two pairs of triangles that are directly congruent, oppositely congruent. Now you are supposed to know these. Just a general remark. Let me clean up here so that I may give my remark. Just clean up this space so that I may put forth a few remarks and take them serious, please, for you to have some good future. Directly congruence. For direct congruence, now the transformation involved is rotation and translation. For us to get triangles that are directly congruent, it should be rotation and translation. Then for opposite congruence or indirect congruence, in this one now, it is reflection that gets involved. So when you reflect, you get triangles that are oppositely congruent. When you rotate or translate, you get triangles that are directly congruent. So from this, you just monitor the transformation that was involved in each particular case. So let's talk about direct congruence. We need to look for, with direct congruence, we need to talk about the second triangle here, which was mapped to the third one here. Therefore, a prime and double prime, there was a translation there. Therefore, it's a direct congruence. In other words, when you lift P prime, Q prime, and R prime, it shall fit in direct in the image without having to tilt it through many angles. Without having to tilt it, it will just fit in. That's what we call direct congruence. Therefore, P, Q, R, and P, Q, R. That's one pair. And P, Q, R with the third one, P triple. Yeah, with the triple like that, because it is an enlargement, because it is a rotation that got involved. So for rotation, once you tilt through a common angle, everything will fit in place. But now for reflection, even if you tilt through a uniform direction, you shall not have the triangle falling into or fitting into the other one. Therefore, the first triangle and the second one, where reflection was involved, that is inverse congruence, or rather opposite congruence. So the first triangle, PQR, and the first image. Now for opposite congruence, PQR and PQR. So that's what you're supposed to know now. You are just guided by the transformation that took place. So you're supposed to be conversant with everything that is happening. Everything that is happening. 18, ladies and gentlemen, this is on constructions and bearings. The location of B is 5 kilometers on a bearing of north, 60 degrees towards east. That's a compass bearing from A. Then the location of B, again, we're still describing B, is 10 kilometers on a bearing of 105 from location C. These are locations, eh? D is directly south of C. When we talk about south, it means directly downwards. When we talk about west, due west of A, west means left and should be horizontally left. When you talk about downwards, it should be vertically downwards. So when you're told that some place is to the west, it means left horizontally. When we talk about east, the place is to the right hand side. So now it will depend on where you are seated. When we talk about south, it means perpendicularly downwards. You move perpendicularly downwards. When you talk about north, it should be perpendicularly upwards. Perpendicularly upwards. So that's what you're supposed to master when it comes to bearings. Using a scale of 1:100,000, show the relative positions. Show the relative positions. Yeah, show the relative positions. So you're supposed to know that this scale means 1 centimeter for 100,000 centimeters, meaning that 1 centimeter shall represent 1 km, because this distance also converted to kilometers now. Yeah, that's what it becomes. So where do we begin with? The first direction to be given is the direction of B from A. So we begin with A. We state the position of A first. We identify A first. So A is here with a compass like that. That's point A. Now with point A, where is B? On a bearing of 60 towards the east. It means you measure from the north towards east in the clockwise direction for you to measure 60. Then you produce, this is a 60 degrees from the north towards east. Then after that, now you measure the 5 km represented by 5 centimeters. So 5 centimeters, that's where B is now. 60 from A on a distance of 5. Location B, the location B is 10 kilometers on a bearing of 105 from C. Just look at that information. So it is C that we don't know. It is C that we don't know. Therefore, you're supposed to just sketch that information roughly. Sketch that information and say, from C, assuming this is C, we will need 105 to locate where B is. If this was C, you need 105, meaning that with 105, you've remained with 75 here. And after connecting them, you also get 75 at this point. You also get 75 as the angle at that point, meaning that now, while at B, you need to measure 75 northwest. You need to measure 75 at that point. So here you measure 75. Measure 75 and you produce the line. You just produce the line like that. Yeah, you produce the line like that. So after you've measured 75 here, now you now get to the distance. you now get to the distance of 10 centimeters for the 10 kilometers. Then you raise your compass at that point. You see now with that compass there, this is automatically 75, meaning that the bearing is now 105 from C to B, like that. Where is B? Directly south of C and west of A. Therefore, while at C, you just move directly downwards, and while at A, you move directly to the west, which means to the left. Now, intersection gives us D. The intersection gives us D, like that. So we have the positions now already illustrated. This is a very technical information whereby you are given the location of B with reference to C, yet you don't have the C. You're supposed to be able to relate in this manner, and you get what is needed. So it's not a very tough, not a tough task. You are equal to the task. Check out the instruction in part B. Very interesting. Now, a water tower is to be erected to serve town A, C, and D. Town A, C, and D. By construction, determine the central position T where the tank should be situated. A, C, and D. A, C, and D. A, C, and D. So let's connect A, C, and D first. A, C, and D. That is the triangle formed by. There's a triangle formed by the three ACD, like that. So if from C, AD, a tank should be at a central position, then we are supposed to bisect any two lines so that in case a circle is drawn from where those bisectors meet, in other words, we are identifying a circumcenter such that now a circle drawn will be accessing or will be touching C, D, and A. So for a circle to be drawn touching C, D, and A, it means that circle should be a circumcenter, should have a circumcenter, whereby we're supposed now to bisect two lines, any two lines. So standing at D, we can make an arc and another arc. Standing at A, we make arcs to cut the first one. Then we produce the bisector of AD. We produce the bisector of AD like that. You're also supposed to bisect the CD. Standing at C, you make arcs and arcs. And standing at C, you cut those arcs. Now, when you cut those arcs now, you'll be able to have bisected CD. You see now, there is a point where the arcs are intersecting. The two bisectors are intersecting. That is point T. So in case you stand at T here and you do a circle, it will touch uniformly A, C, D, meaning that the point T we have identified is exactly at the center. So that's basic construction, but the question requires a lot of understanding of geometry. You should be knowing what you're doing in such a case. A very good question. Very good question. The next. Look at part C. The question says, you determine the compass bearing and distance of B from D. B from D. B from D. So first thing you are supposed to join. You join B and D first, because you can't talk about bearing until the 2 points are connected. You can't talk about bearing until you connect the two. Perfectly connected. Now, after connecting them now, you first measure the distance. And when you measure this distance from D to C, I want you to try the question. You find that is 10 centimeters. 10 centimeters. So the distance of B to D is 10 kilometers, whereby we add or minus 0.1. The distance is already in kilometers because we are finding centimeters and every centimeter represents a kilometer. So we don't incur a lot of steps in converting. We don't incur a lot of steps in converting. Yeah, remember 1 centimeter represented what? According to the scale, 1 centimeter represented 1 kilometer. Then what about the bearing now? What about the bearing? What about the bearing? Look at this. The bearing, you know, we need the bearing of what? B from D. B from D. While at D, how do we access B? So the angle should be from the north. You now measure this one, which is 75 degrees. That is the only acute angle connecting them. Because if we measure from the south, it shall not be acute. It shall be greater than 90. So now this is 75 from the north towards east. So from the north, 75 degrees towards the east. That is what you call compass bearing. You identify the acute angle joining the two places from either north or south. If we consider south, while at D, the angle here, the angle there is greater than 90, it's not acute. So it can be from south towards east. It must be from the north towards east, like that. Then look at the next one now. We also determine the true bearing and distance of water from location A. So from location A to the water tower, that means first we connect the water tower to A. We connect the water tower to point A. So the water tower is directly connected to point A, directly connected to point A like that. Then after connecting them now, start talking about now the bearings and distance. And for this case, we need true bearing and distance. The distance measured is 3.7. When you measure that distance, you get 3.7. These are centimeters and also kilometers, but you will be considered within an accuracy of plus or minus 0.1 kilometers. So if you get 3.8, 3.6, you are within the limits. So true bearing now. True bearing must be measured from the north and in the clockwise direction must be stated in 3 digits. If it's 2 digits, you introduce a 0 at the beginning. Therefore, now we measure from the north all the way, and we get 314 degrees, whereby for angles, we consider an accuracy of a whole degree. So it can be plus or minus 1. Thank you for joining us. Please remember to subscribe. Remember our consultation line. Remember our consultation line is 0704 15 3366. We are still wishing you success from Shifting Grades Online School. Look at number 19, ladies and gentlemen. It's a very good question. The question says that a rectangular sheet of metal has its length being 4 centimeters longer than its width. Now, squares of side 2 centimeters are cut from each corner. And the sheet and the sides, okay? And the sides are folded to make an open rectangular box. Look at part 1. Look at part 1. We are told taking x as the width of the rectangular sheet, write an expression in x for the volume of the rectangular box. For the volume of the rectangular box. Therefore, this is what we are saying, that the width is x. What shall be the width? The width has been let, want us to consider it keenly. The width has been let to be x. Then the length, according to this information, the length shall be what? Length 4 centimeters longer. 4 centimeters longer, meaning that 4 plus x. That is now the measurement of the length. Then squares of side 2 centimeters. Squares of side 2 centimeters are cut from each corner. They are cut from each corner. So now when you cut from each corner, if you cut from each corner now, you should be talking about new length and new width. And I'm going to use a diagram so that you people may understand now what we mean by cutting from each corner. So this is the metal sheet that we're having. This is the metal sheet that we're having. We already given that this one is x plus 4. And here it's x, which is the width. But now we are cutting 2 centimeters here by 2 centimeters there. 2 by 2 from each corner. So along the width, we will have cut, if we are cutting 2 by 2, along the width, this 2 by 2, along the width, we shall cut a total of 2 here and a 2 here, making us cut 4. So the new width is x less 4. The new length shall be, along the length again, remember this is also a 2 here by 2. So along the length, we are cutting 2 and another 2 here, meaning that we are subtracting 4 also. So x plus 4, now we subtract 4 and remain with only x, like that. So we have an expression for the new width and an expression for the new length. Taking x as the width of the rectangular sheet, write an expression in x for the volume of the rectangular box. So the volume now, the volume shall be when you fold up these. When you fold up these, I want you to know something. It's like now we are getting to some hard work here, some juakali work here. We've cut some squares at the ends. So when you fold now, you get a box which is now rectangular based and has a height of 2. The 2 here becomes the height, but now the rectangular base has the measurements of the new width and length here. Therefore, the volume shall be length times width, meaning x. The volume will be x times width multiplied by the height of 2. So this will be x squared minus 4x. There is a 2 here. So now the volume expression shall be 2x squared minus 4x. No, 4 multiplies also by the 2. And remember, the simplified expression can also remain like that instead of opening the bracket. Yeah, it can be a simplified expression. Anyway, that is it. So that is the expression for the... So when you imagine this one being some practical work, when you fold this width, the length there and this width, the parts which we removed, square parts, now they shall become the heights. It becomes the perpendicular height. So that's why we are using 2 as the height at that point. Then the part B of this says that given that the rectangular box has a volume of 192 cubic centimeters, find the dimensions of the rectangle. Find x first. So you say 2x squared minus 8x equals to 192. Remember, you can divide by 2 through to get x squared minus 4x equals to 192 over 2. Is it 96? Yeah, just a confirmation. 96. Then at this point now we can talk about completing the square method, whereby x squared minus 4x, we add a constant, and the constant is given by b over 2 squared. So negative 4 over 2, and we square. We get 4. 96, we also add the same constant. So now we have completed the square on the left. The square on the left has been completed, meaning that now we can factorize. Factorizing a perfect square means square root of this part, the sign that follows, square root of this part squared equals to 100. Then after that, now you can obtain square root of both sides. Obtain the square root of both sides. Now, obtaining square root for both sides means x minus 2 equals to plus or minus 10. That's after the square root. That's after getting the square root. Now with this, we can now proceed and talk about what? We can proceed and talk about the value of x being either the positive part of the square root plus 2, sorry, up there. So 10 plus 2, or x equals to negative 10 plus 2. You know, this will give us negative 8, but the first one will give us 12. Now that we are dealing with length, the value of x cannot be negative. Therefore, because it's a distance, then we settle for x equals to 12. And this one is centimeters. This one is now x is the length of the box. X is the length of the box, meaning that the width of the box is 4 minus x minus 4. X minus 4. X minus 4 gives us 6, meaning that the box measures 12 centimeters by 6 centimeters, then by 2 centimeters. That is now the meaning of dimensions. So that's how the box measures. That is simply how the box is measuring. Yeah. Those are the dimensions of the rectangular box. Now at part C, a tank similar to the rectangular box has a length of 10 meters. Find the capacity of the tank. The key word here is similar. So we're talking about similarity. It has a length of 10. What about the box that we have? It had a length of 12. Meaning that we can talk about linear scale factor. Linear scale factor. When we take the length of the real tank, 10 meters, we can make it centimeters by multiplying by 100. Then we divide this by the length of the model box there, 12. What is the simplified format of this? 500 over 6, right? So we can divide by 4. We can divide by 4 to get, yeah, we can divide by 4 to get 250, I think, yeah. And this one is 3. This is now This is now the linear scale factor. When you compare lengths of the model or of the similar box, and now the bigger tank, which is similar to this. It means they also share what you call volume scale factor. Volume scale factor. So the volume scale factor will be when we cube 250 over 3 power 3 over 27. So we're supposed to cube 250 to give us 15,625,000. That is now the volume scale factor. And remember, we are having volume of the smaller. We are having volume of the smaller. If we have volume of the smaller as 192, then we can get volume of the bigger. So we say, when we take volume of the bigger, which is unknown, we can call it y. I think x has been overused. We are dealing with x in part A and B. So now we can check something else like y. Yeah, something else like y. Trying to clear up this. In case we take y, which is now volume of the bigger triangle, out of 192 volume of the smaller, we are supposed to get the volume scale factor. 1, 5, 6, 25 thousandths. Out of 27. So how shall we remain with y? We multiply by 192 out of 27. This gives us exactly 111,000,000.1 cubic centimeters. Now that we talked about capacity of the tank, then we should talk about liters. Because we talked about capacity and not volume. Capacity and not volume. Then we can divide by 1,000 to get liters. These are cubic centimeters. So we get 100.11 liters. So this is now the capacity of the bigger tank. That is now the capacity of the bigger tank. Capacity of the bigger tank. Yeah. So that's how you're supposed to work out such a question. That is how you're supposed to work out such a very good question. Remember to subscribe. Remember to share so that you may invite your friends to our wonderful discussions, our wonderful questions here. Proceeding to statistics 1. Proceeding to statistics 1, number 20. Now, below are marks obtained by 40 students in an examination. Fill in the table below. Fill in the table below for the frequency of the marks given. Here, I must come up with what we call a tallying column. So allow me use the space here. We can rub it later. Allow me use it as the tallying space now, so that if I mark 5, for example, I place a stick at 5. If I mark 16, where does 16 lie? Here. 17, same class. 18, same class. 42, where shall 42 be here? 30, where shall 30 be? This point. 31, same class. 33, same class. 32, 27 here. 36 here. Then 37 here. 39, that class. 41, now 41, we wrap these ones because they are already 4, like that. 25, 25, this is the class, we wrap them, they are already 4. Then 4, 5, the last class here. 4, 5 again, same class. 4, 8, same class. 40, we start again there. 4, 3, same class. 10, the first class. 17 here. 18 here. 19 here. 24, same class. 31, we wrap these ones. 19, we wrap these ones. 33 here. 32, same class. 43, the last class there. We proceed to 36, right? Here, we continue tallying. 38 lies here. 40, where does 40 lie? We wrap these ones. 42, same class. 28 here. 20 exactly here. 48, we wrap these ones. 38 here. 41 here. And finally 40. Same class. So now we can compile the tallying now. We now tally. These ones are only 2. Let me submit now the values after tallying. These ones are only 2. So you see the tallying column makes it very efficient. To first place, every value in each class. Then now you compile the tallying. This is 5, 5, and 2, making up 12. This is 5 and 2, making it 7. This is 5, 5, and 4, making it 14. Then we have exactly 5. Yeah, exactly 5. Like that. Can we add up 2 plus 12? We get 14. 14 plus 7, 21. 21 plus 14, 35. Plus 5, 40. So it's 40. Exactly 40. That's a good one. That's a very good one. So we have distributed every mark to its class. Properly distributed. Now, I want to mention something here. As we continue learning. We have our serious programs here for the holiday. And actually, I'm inviting, through your teachers, through parents, through elder brothers, I'm inviting all learners in continuing levels. From the 20th of November to the 12th of December, 2025, we shall have a Google Meet classes, very interactive classes. And in these interactive classes, we shall be covering the term 1 work of 2026. So 2026 work shall be introduced, meaning that everybody shall be introduced to the work of their next level, The junior school and also the senior school, you are most invited. Yeah, our consultation line is already attached on the wall. Our till number is already attached. The same consultation line is also functional in the M-Pesa, so you can use our line and our till number to appreciate our good programs here. So let's proceed with now the statistics question. we proceed with the statistics question. So we're talking now of number 20B. On the grid provided, draw a histogram to represent the data. Now, when I look at the nature of these classes, ladies and gentlemen, when I look at the nature of the classes, it is very evident that these classes are not equal in length, in width. So class width, class interval, class sizes, they are not the same. Look at 5 to 14, 15 to 29, then 30 to 34. You see, 30 to 34 has a width of 5, but others have too wide. 45 to 49, a width of 5, but the others are so broad. So when class intervals are not the same, you're waiting for the KCSE 2025 and you've never known how to present data, to represent data on histograms. Just be informed that histograms are of two types. You may have equal intervals. When intervals are equal, you're supposed to plot frequency against the class boundaries. Frequency against class boundary. That is for equal class intervals. But in a case like this, where the intervals are different, then we establish another row or a column, depending on how the data has been placed. Another row containing what we call frequency density. And how is frequency density obtained, ladies and gentlemen? Frequency density is obtained by, so we come up with FD, is given by frequency over class width. So now we'll be plotting frequency density against the boundaries. Yeah, frequency density against the boundaries. So let's check. The first frequency is 2, and 2 shall be divided by the class interval. So we take the upper limit of 14.5 minus the lower boundary of 4.5, giving us 10. So 2 over 10 shall be 0.2. Next, 12 divided by, we consider 29.5 as the upper boundary minus 14.5 as the lower, 15. So 12 over 15, this gives us 0.8. 0.8. The next shall be a frequency of 7 divided by, when we take 34.5 and we subtract 29.5, the interval there is 5. So 7 over 5, this gives us 1.4. Exactly 1.4. What about in the next? We talk about frequency of 14, but the interval should be 44.5 minus 34.5, giving us 10. So that will still be 1.4, 14 over 10. And finally, 49.5, that's the upper boundary, divided by 44.5 minus 44.5. That's a class width of 5. So frequency of 5 and class interval of 5 gives us a frequency density of 1. So we have the frequency densities now already established. Frequency densities already established. So on the grid provided, we are now drawing a histogram. And what have I just mentioned? That histogram, when class intervals are not the same, we use frequency density against the class boundaries. So frequency density takes now the vertical axis. So we shall have the frequency density there. Then along the x-axis, we shall have the class intervals. Not the class intervals, but the class boundaries. So we'll have the marks here in the class boundaries like that. Let's look for a suitable scale for the vertical axis. We can use intervals of 0.2 because 0.1 may cost us, at the time we shall move to 1.4, we shall require 14 boxes. So we can start from 0, then we go to 0.2, 0.4, 0.5, intervals. Scale should be uniform and continuous. Sorry for that mistake. 0.6, 0.8, 1.0, 1.2, 1.4. You see, we have accommodated now 1.4, which is the highest, 1.6, like that. So we have now the vertical axis properly plotted. That's the vertical axis. What about on the horizontal? The first class is having a lower boundary of 4.5. So we start with 4.5 unless the examiner wants us to install what we call a frequency polygon, but it's not required. So actually we can assume a previous class that begins from 1 to 4. Then we plot this class that starts from 1 to 4. So we start from 0.5 to 4.5. 0.5. So instead of breaking the axis, you bring your first point to the initial stage. Now, when we use intervals of 5, shall we accommodate 49 really? You know, to accommodate 49 with intervals of 5, we will need 10 classes. We need 10 squares here. 1, 2, 3, 4, 5. Yeah, 10 are there. So let me go to the upper of 4.5. 4.5. Have I really used the right interval? 0.5 to 4.5, yeah. 0.5 all the way to 4.5. Or, allow me not to complicate this scale. Allow me use uniformity. Let me examine the data keenly. Back to the data. From 4 to yeah. So we can talk about intervals of 5. Intervals of 5. So let me start with the least lower boundary here, which is 4.5. Please allow me start with 4.5, the least boundary there. 4.5. Then when I go to, I use intervals of 5, I should go now to 9.5, 14.5, 19.5, then 24.5, then 29.5, 34.5, 39.5, 44.5, 49.5. Can even talk about 54.5. So all the values have been accommodated. All the values have been accommodated. So the first class starts from 4.5 to 14.5. And the height is the frequency density. So the height shall be 0.2. The height shall be 0.2. The next class, starting from, sorry, the next class is starting from 14.5 to 29.5, and the height is 0.8 to 29.5, and the height is 0.8. So that's how the class shall be, a bit broader than the first one, and also with a bigger height like that. Look at the other one, from 29, the lower boundary, to 34 points, and the height is 1.4. The height is 1.4. like that. 1.4 like that. The other one from a lower boundary of 34.5 to 44.5, then the same height of 1.4. Yeah, is how it is. We proceed with plotting the last class from 44.5 as the lower boundary all the way to 49.5, and the height is 1. The height is 1, so we can place our bar there. That is the height. That. So now we having all the classes represented. Okay. Classes properly represented. I hope you can see. I hope you can see the work from that side. I hope you can see what we are plotting from that side. Frequency density against the class boundaries. You come up with a very decent histogram representation of data. Now look at part C of this. Part C of this says, draw a vertical line on the graph above to indicate the median mark. You've not been even told to find the median. You've been told to draw a vertical line to indicate. So we shall both draw and also determine. Now, I want you to know that according to this data and according to the frequencies here, because of space, allow me just clean up here. So allow me clean up that because we have already used it. Allow me talk about some CF cumulative frequencies. This is 2, this is 14, this is 21, this is 35, and this is 40. So when we take 40, the total frequency out of 2, we get 20. So where is the 20th student? The 20th student is in this class because this is 21. So the 20th student is there. Now, median is the mark that has been scored by the 20th student. That is the mark scored by the 20th student, and we should be able to determine it. We are supposed to be able to determine it. Therefore, the thing here is we first check how many people or how many students are in the first class. Let me change my color to, let me use this green here. In the first class, how many are they? There are only 2. Then up to the second, how many have been accommodated? 14. So far, 14. In other words, there are 12 of them. There are 12 in the class, but so far, we have talked about a total of 14. So for us to reach the 20th, we don't need all the 7. We don't need all the 7 in the second class. And it's also good for you to know that whenever you are dealing with these classes or this type of a graph, the area of the bar gives us the number of students in that class, the frequency there. Because frequency density is given by frequency over width. Then it means to get back frequency, we need frequency density, which is the height times width. The width is along the x-axis. Therefore, because we have already handled 2, this is not very clear. We have already handled 2 and we've handled 12. That's 14. We need 6 more, and we need 6 people in the next class. 6 people in the next class. Therefore, we don't need the 7 of them, because when we consider the 7 of them, we shall have gone to the 21st student. So we need exactly 20 people. So we are only adding 6. Now, how would we get 6? The height is fixed. The height is fixed. So how can we change the area of the height now to give us the area of this graph to give us only 6? Only 6 people. Therefore, we will say this, that we have a fixed height of 1.4. We need a frequency of 6 from this second class, and we have a fixed height of 1.4. So it should multiply some unknown width. It should multiply some unknown width to give us 6. So W equals to 6 divided by 1.4. And that is 4.286. 4.286. That's what we should consider now along the x-axis, so that when multiplied by the vertical height of 1.4, we get our 6. You see, roughly, this is around 4.3. So we consider adding 4.3 here. We consider adding 4.3 here. We consider adding 4.3 along this. So we can count 1, 2, 3, 4, then point something, 4 point something, 4.3. So when you add 4.3, then this particular, the particular mark shall be somewhere just after 4 and before 5. Just after 4 and beyond 5. Just after 4 and beyond 5. This now becomes the median. That is the median height, the height to show us median. And if we are getting the median itself, then we would have said after 29.5, we are adding 4.286. This gives us 33.786. 33.786. That is the median. Though we just want the vertical height. It's good for you to know that according to the formula, median is given by lower boundary of the median class plus total frequency over 2 minus cumulative frequency before out of frequency multiplied by the class length. So in our case here, guys, we are talking about a lower boundary of 29.5 plus total frequency 40 over 2 minus cumulative frequency before the median class. Just before the median class, we had 14. Median class as a cumulative frequency of 21, but before median class, we had 14. So we subtract 14 here. Divide by frequency of this class. Frequency of the median class is 7. Multiplied by the class interval, or rather class length, from, that's a 5. 30 to 34. That's 5. Yeah, that's 5. So can we compute this now? 29.5. What are we adding to 29.5? What are we adding to 29.5? So we check that. 21 minus 14, we get 7. 29 minus 14, we get 7. And now 7 should be multiplied by 5. Then we divide by 7 and we get exactly 5. Now when we add 5 to 29, 29.5, we are getting 34.5, which is almost the same estimation. Wait, 40 divided by 2 is 20, minus 14, we get 6. 6 times 5 over 7. 6 times 5 over 7. Actually, we're getting the same, 4.286. And we get the same answer. So using the formula and also using the graph, the answer should be the same. The answer is supposed to be the same. Let's look at number 21, ladies and gentlemen. we must go through the full paper. We shall discuss everything in this section too. So please stay tuned until we revise everything. Now, a sector of a circle of radius 14 centimeters subtends an angle of 120 at the center of the circle. Take pi as 22/7, then calculate the exact length of the arc of the sector. Arc of the sector. So arc length is usually given by arc length, just to start with the formula, beta, angle at the center, out of 360, 2 pi times radius. So beta over 360, 2 pi r. Beta over 360, 2 pi r. Then this now should be computed faithfully. That should be computed faithfully. And then we shall get exactly 29 1/3. The meaning of the word exact. 29 1/3 centimeters. Now, the meaning of the word exact means you're not supposed to round off the answer. If it is not an exact value, then write the decimal. Write the decimal. If not so, then you would have written 29.33, but now you show that the 3 is recurring. That will be another way of making sure that it is exact that way. But when you write it as 29.33 for significant figures, this is not exact. This is a rounded off. This is a truncated value. So you do some clean work by ensuring. That you ensure that you obey instructions like the word exact. Very intentional. It has just not been placed there. Now, the sector is folded. The sector we had there is now folded to form a cone by joining the straight edges together. Find the radius of the base of the cone, correct to 1 dp, correct to 1 decimal place. So when you fold a sector, it becomes a cone. I don't know whether it's possible. I described that using the camera, though I'd not prepared for the same. But in case a sector is folded, it usually becomes a cone. I think that is something I should have demonstrated. Let me cut some piece of paper here so that I may show you. But basically what we mean is that when you have a circle here, you obtain a sector from it. This is a sector. Now, when you fold the edges of this sector, this part and this part, when you bring them together, the part here, the arc length of the sector becomes the base circumference, because a cone now will look like this. A cone will look like this now. So the base circumference is the curved, the base circumference is the arc length of the sector. And the slanting height now becomes radius. Slanting height becomes, look at this, R becomes slanting height. But now the cone formed will have a different R. I don't know now whether you get that concept. The cone being formed will have a slanting length that is equivalent to the radius of the sector forming it. So slanting length will be equal to the radius of the sector that has been folded. So when you fold a sector, whatever was radius now changes to a slanting height. Then now the cone formed now will possess a different radius at the base. That is the radius we want. One thing that we're supposed to know is that the area of the sector now becomes the curved surface of this cone. So this surface this surface, which was a sector, now becomes the curved area at the cone. And we know that. So we are saying that sector equals to curved surface area, meaning that area of the sector, which was theta over 360 pi r, a radius of 14 times a radius of 14 radius squared. Theta over 360 pi r squared. That is area of the sector. Now it changes to the curved surface of the cone formed. Curved surface of the cone formed will be given by pi r, unknown, times L, slanting length. So for the curved surface, we talk about pi RL, where pi is a constant. Then with pi as a constant, we're supposed to know that R is the radius. And the radius for this cone is unknown. Then L, slanting length, is now the radius that was for the sector. It now becomes a slanting length. So in the whole expression, the only unknown is the radius of the cone that has been formed. And we can find it very quickly and conveniently. By cancelling out a few similar factors, like pi is appearing on both sides. Then we got a 14 and some other 14s there. One cancels. So now the value of R shall be, allow me adjust the paper so that you'll be able to see everything clearly. So when you cancel pi from both sides now, the value of radius can now be obtained by multiplying 120 out of 360 by 14. You see, this gives us 4.666, but we've been told correct to 1 dp, so 4.7 centimeters. 4.7 centimeters to ensure that you stick to the instructions. Stick to the instructions. So now the cone formed is having a slanting height of 14 and a base radius of 4.7. Look at part C. Look at part C. At part C, we've been told that a FRUSTUM is formed by cutting off the top of the cone such that the smaller cone removed has a slant height of 9. Find the curved surface of the FRUSTUM to the nearest. Find the curved surface of the FRUSTUM to the nearest whole number. So now we are having a cone here. Let me now draw the information well about this cone now, because more details are coming. That. Look at that. So we are told now somewhere along, of course, it is cut at a plane which is perpendicular to the base. Perpendicular to the base. Meaning that slanting height of 9 has left, it was total 4, so it has left 5 here. Like that. Total was 14. Remember, total was 14. Total slanting height. That was 14. So now the slant height being cut off. Slant height being cut off here is 9. The smaller cone removed as a slant height of 9, like that. Now it's good for you to know that using what you call similarities and enlargements, we can also know what the radius, because radius here radius here has been computed as 4 2/3, then we can say the ratio of, because they are both linear measurements, the ratio of the radii is the same as the ratio of the slanting heights. So 14 out of the 9 that was cut should be the same as 4 2/3. You know, this is 14/3, right? Yeah, 14/3 should be the same as 14/3 14/3 divided by a known radius. Is it 14/3? What are we talking about here? Yeah, 14/3. 14/3 divided by 14/3 out of a known radius there, a small radius that was cut off. Therefore, we can multiply 14 by x after cross multiply equals to 9 times 14/3, like that. How will you remain with x? You divide by 14 through, so you get exactly 3 centimeters. Is that true? Yeah. Times 9/14. I'm getting 3 as the answer. Exactly 3. Because 9/3 is 3, and 14 will cancel from both sides. So now, the smaller cone which was cut is having a radius of 3. So now we can say the curved surface of the FRUSTUM being obtained of the FRUSTUM shall be pi RL, the original cone, minus pi RL, the smaller ones now, the smaller dimensions. So the original one is already, actually we didn't compute it. We had not computed it. So 22/7 times a radius of 14/3 times a slanting length of 14 minus 22/7 times a radius of 3 and a slanting edge of 9 for the smaller cone. So what does this give us, ladies and gentlemen? What does this give us? 22/7 multiplied by 14/3 multiplied by 14. That gives us 205 2/3 and a third, minus 22/7 by 3 by 9, giving us 84 6/7. 84 6/7. Now we can talk about the difference here. Yeah, we can talk about the difference. When you subtract 205 and a third from this value, we are getting 120 and 10/21. But now the instructions are talking about nearest whole number. So this is 120.47, which is just 120 square centimeters. Yeah, 120 square centimeters. That becomes now the final answer. Do you see the question is good? Do you see the question is very interesting? A very good question. Very, very good question. So let's proceed now to number 22. We proceed to number 22. We've been told that a horse participated in a 60-second timed sprint. Now the velocity time graph of the horse motion is described below. From 0 to 10 seconds, the horse accelerated uniformly from 0 to 30. From 10 to 30 seconds, the horse maintained a constant speed. And from 30 to 50, the horse accelerated uniformly to its maximum speed of 60. All right? Then from 50 to 60, the horse decelerated uniformly to rest. Draw velocity time graph for the race. Velocity time graph. So we shall have velocity on the vertical axis and time on the, we just actually, this is velocity in meters per seconds. Then what we have, along this? Time in seconds. From 0 seconds to 10, the first 10, we have a uniform acceleration all the way to a velocity of 30. Yeah, velocity of 30 meters. So uniform acceleration means a straight line. Then after that, it's after 10 seconds. For the next, up to 30, for the next 20, we shall have it maintaining that velocity. So there is change in time, but velocity is not changing. Change in time, but velocity is not changing. So it has been maintaining for that time. Then after this now, up to 50 seconds, we will have acceleration to 60. So we will have, by the time to 50th second, we will have acceleration now to 60. So here we talk about, or let me sketch 60 at this point. 60 that point. So now we will have it now. Yeah, like that. Then after that, now there's something that will happen is that by the time it's going to 60, by the 60th minute, it will have decelerated to 0 to rest. It will have decelerated to rest. So this is a sketch of tentatively what is happening now with this particular horse participating in a sprint race. Now this is what is happening now. You sketch the motion like that. Then after sketching the motion, there is something I want us now to check, calculate in part B. There is a Roman 1 there. There's a Roman 1. You've been told to calculate the acceleration in the first 10 seconds. Acceleration means gradient of this particular straight line. First 10 seconds. Acceleration will be given by gradient. This is, we have time 10 and 30 velocity. Then we add 0, 0. That's what you're supposed to know. So 30 minus 0 and 10 minus 0. This is 30 over 10, giving us 3 meters per second squared. So acceleration is usually the gradient of velocity time graph. So within the first 10 seconds, there was a uniform acceleration of 3. Determine again the deceleration in the last 10. Deceleration. We talk about acceleration here. We are having 50 minutes, 60 velocity, 50 speed of 60. Then it changed to time 0, 60. Time is 60. Velocity became 0. So when we find acceleration here, then we'll be talking about 0 minus 60 out of 0 minus 60 out of 60 minus 50. So this negative 60 over 10. Yeah, minus 60 over 10, giving us negative 6 meters per second squared as the acceleration. If that is the acceleration, then the deceleration shall be the positive. We now omit the sign. So when we talk about deceleration, it is simply negative acceleration. So we take absolute value of negative acceleration for us to get deceleration. Absolute value of negative acceleration. Absolute value of negative acceleration is what gives us deceleration. Then now there is a Roman 3 of the same question. Roman 3 of the same, the question says, total distance covered. For us to get total distance covered, when we are given velocity time graph, total distance equals to area under the graph. Area under the graph. So let's find area under the graph now. We can divide it into different shapes. Different shapes, for instance, we can talk about the trapezium there, another trapezium, and the final rectangle and the final triangle. So you can divide it into 3 portions like that. So now you can say, according to the first trapezium, so we'll have 1, 2, and 3. Let's talk about area 1. You know, the upper length here is moving from 10 to 30, so that's at 20. But bottom here we have 30. Then in between we have another 30. So you say area 1 equals to half the sum of the two sides, 20 and 30, and the height between them. So 50, that's 25 by 30. That's 750. 750 meters. Area 2, which is also trapezoidal in nature. We shall need parallel sides, whereby we are having 30 and 60 here. So half, 30 and 60. Then now between them we have a height of, from 30 to 50, this is 20. That's 20. So I'm having 90 inside the brackets. Then 10 outside, that gives us 900. 900 meters. Then we have the third one. So that now we add. Let's talk about the third area. Area 3. Area 3 shall be equal to. Let's look at area 3, ladies and gentlemen. Let us look at area 3. What is the shape of area 3? What is the shape of area 3? The shape of area 3 is triangular. Vertical 60 and base 10. Yeah, that's a 10. I hope you can see where the 10 is coming from. 50 to 60. So half times 60 times 10. Half times 60 times 10. You know, this will give us a 600 over 2, which is 300 meters. Total calls for addition now. 300 here, 900, 750. So we're getting 1950. That is the total distance. Just find the area under the graph. A very good question. Very good question. Let's check number 23 on matrices. Now, given The matrix A is 2, 3, 3, 4. Find A inverse, the inverse of matrix A. So for us to find inverse of a matrix, ladies and gentlemen, we're supposed to first find determinant. The determinant of this matrix calls for product of elements in the leading diagonal, 2 by 4, minus product of elements in the other diagonal, 3 by 3. 8, we get -1. Then now for us to get determinant, we need to change the position of the elements in the main diagonal. 4 comes here. Sorry. 4 comes here, and 2 takes this position. Then for elements in the other diagonal, we change their symbol. We change their sign like that. Then after that, every element should be divided by the inverse. Everything should be divided by the inverse now. And the inverse is -1. So when everything is divided now by -1, we will have the final answer as, we'll have the final answer as -4. 3 now becomes positive. This becomes 3. And this becomes negative. We divide everything by -1. So this will be the final matrix, which is the inverse now. Then part B. We're almost winding up, ladies and gentlemen. We are almost winding up. Let's interpret the information in part B. John bought 200 bags of sugar and 300 bags of rice for a total of 850,000 Kenya shillings. Jen bought 110 bags of sugar less than John and 180 bags of rice less than John at a total of 360 Kenya shillings. If the price of one bag of sugar is X and that of rice is Y, form two simplified equations. Underline the word simplified and to represent the information above. To represent the information above. Okay, let's proceed by doing this. Let's do this. According to the statements that we can see here, according to these particular statements, we can say that 200 times a bag of the price of a bag of sugar, which has been let to be X, then plus 300 times the price, we would talk about 850,000. Can we simplify this? Yes. And this will be 2x plus 3y equals 2. I'm dividing through by the zeros. 8, 5, and 2 zeros instead of 4 zeros now. Like that. What about the second information? Jen bought 110 bags less. 110 bags of less. So 200 minus 110 bags, we get 90 times X plus 180 bags less. So 300 minus 180. You know, this is giving us now 120 by Y. Now she spent 360. We can still simplify this also. And when we simplify this, we can divide by 30 all through. By 30 all through, we shall get 3x plus 4y equals to 36,000. That is 306,000 over 30 gives us 120,000. Now there's something I didn't check well in the previous question. The zeros were 4 and we divided by hundreds. Yeah, divided by 100. Yeah, that's okay. That one is very okay. So we have equation 1 and equation 2 properly simplified. Properly simplified. I've discovered that in the second equation, we have simplified by a very small value. That is why here it's a bit bigger. Use the matrix inverse of A to find the price of one bag of each item. Remember this. In case you fail to simplify well, you will not be able to use the matrix that was used up there. Because when you extract something called matrix equation here now, from the coefficients, we extract what we call a coefficients matrix. And it shall be 2, 3, 3, 4, multiplied by what we call variables matrix, X and Y, equals to the constants matrix, 8500, 1, 2000. So these are matrix equation now. Call this one a matrix equation. A matrix equation. So with the matrix equation now, we can proceed to simplify it. How do we simplify a matrix equation? By pre-multiplying by the inverse of the variables, by the inverse of the coefficients matrix. So the inverse of the coefficients matrix was computed here, and it should be correct for it to continue bearing fruits. Negative 4, 3, 3, negative 2. Negative 4, 3, 3, negative 2. That is the inverse. That is the inverse. You see, the coefficients matrix we are getting here is the same as matrix A. Therefore, the inverse now is the same. Now we shall talk about, everything now remaining the way it is. You multiply, so it is the one to start here. When you make a mistake of bringing it later, it shall not make sense to you, and it shall give you wrong things. Like that. So now something else that you're supposed to multiply to know before you multiply matrices is that a matrix multiplied by its own inverse gives us the identity matrix. Identity matrix is a matrix with 1, 0, 0, and 1 times xy. So we don't need to carry out this computation of matrix A and its inverse. We simply get any matrix and its own inverse should give us the identity matrix. This is equal to, now we multiply here, row times the column here. So negative 4 into 8500 plus 3 into 12,000. This gives us 2,000. Then 3 into 8500, negative 2 into 12,000. This gives us exactly 1500. So now we can say the value of x now. Okay, for the value of x, let's continue multiplying matrices. At this point, we can say the identity matrix times any matrix, the matrix remains unchanged. So xy identity matrix times any other matrix, that other matrix remains the same. So we've now found the values of x and y. And so we can say sugar 2,000, rice 1500. Roman 3. Later, the price of sugar decreased by 5, while that of rice increased by 20. Find the difference between the amount added by John and the amount added by Jane. Okay. I think the information is sufficient, but we try to interpret it to the best of our knowledge. Let's check first. Sugar became 95% of original. So the price of a bag of sugar became 1900. This is for sugar. Then for rice, it increased. So it increased by 20. So 120% of the original. This became 1800. This is for rice. That's now for rice. Okay. So now, with this knowledge now, we need to find the difference between the amount added by John and the amount added by Jane. So John will be purchasing what? 200 by X, 300 by Y. John is going to purchase, I'm assuming now they are going to purchase the same number. 200 times now 1900 plus 300 times now this 19. That's 19. 19 like that, 300 by 18. So meaning that to purchase the same amount, they are going to incur different. This one will spend 920,000. Find the difference between the amount added by John. So how much will he add? He shall add, initially, he had spent 850. Initially, he had spent 850,000. So now he's going to add 70,000. Let's check the other lady who is Jen. Jen is going to purchase 90 and 120. 90 and 120. So 90 by 1900. 120 by 1800. So she's now going to incur plus 12 20 into 1800. So she's going to incur 387,000, meaning that she shall add. Earlier, she had spent 360,000. So how much is she adding? She will add 27,000. Therefore, John will add 70,000 while Jane adds 27. So the difference in what they are adding, means 70,000 minus 27,000. This gives us 43,000. That is the difference in the amounts added. Difference in the amounts added, assuming that they went to the same market to purchase the same number of items as they did before. We can check the last question, ladies and gentlemen. A very interesting question. Now, in the final moment of UEFA, a ball traveling in a straight line passed through a point O with an initial velocity of 15 meters per second. Initial velocity of 15 meters per second. Initial velocity of 15 meters per second. Want that one underlined. So that means that one alone at time equals to 0. When we talk about initial velocity, we mean when time was 0, then V was already known to be 15 meters per second. Yeah, 15 meters per second. Due to the pitch resistance, the ball acceleration at a time t seconds is given by acceleration A equals to 2t minus 8 meters per second squared. Find part A, the expression of velocity after passing the point O. Now we're supposed to know that for us to get velocity function, we need to integrate acceleration function with respect to time. Acceleration with respect to time. Therefore, now velocity function generally shall be equal to, we now integrate these. You know, the power of t becomes 2, but the new power should divide everything, making 2 divided by 2 to cancel out, minus 8. T is introduced there, then plus arbitrary constant c. Now, at that point, let's now talk about the information given here, that when t was 0, initial velocity was already 15. So v equals to 15, you substitute when t was 0, meaning that the c is 15. And now a velocity specific equation can be given instead of the general equation. Instead of the general equation, now we give a specific equation that v equals to t squared minus 8t plus 15. Yeah, plus 15 that way. Find the time when the particle is at rest. For a particle to be at rest, it should be having a velocity of 0. Therefore, we say t squared minus 8t plus 15 equals to 0. When a particle is at rest, it is moving at a velocity of 0. So now we can say product of 15 by 1, 15, and a sum of the value at b. I want to use the factorization method. Sorry, I want to use the factorization method. So now this shall give us 2 factors when added, negative 8, when multiplied, positive 15. Should be negative 5 and negative 8. So t squared minus, can talk about 5t, then minus again 3t. Instead of negative 8, we talk about negative 5 and negative 3, then plus 15 equal to 0. After every 2, we factorize. When we factorize there, it is only t that is common. So we remain with t minus 5. T minus 5. Then in the other 2, these ones, we factor out negative 3. We remain with the t and a negative 5. This is equal to 0. At this point now, ladies and gentlemen, we should be in a position to say that inside the brackets, we are getting t minus 5. And outside the brackets, we have t minus 3. This is now equals to 0. With the t equals to 0, can we talk about the first t being equal to 5 seconds and the second t being equal to 3 seconds? Yeah. 5 and 3. So those are the moments when the particle is momentarily at rest. Then now look at the next question after that. Just look at the next question after that. Find the distance between the points when the particle is at rest. The particle is at rest at t equals to 5 and also at t equals to 3. Therefore, we can say, for us to get velocity function, distance function first, which is displacement s. We need to integrate velocity with respect to time. Velocity with respect to time. Therefore, with this, let's talk about displacement function. And this time we are very specific because we want the displacement from the 3rd second to the 52nd. Therefore, we will be now integrating from the 3rd to the 5th the function t squared minus with the t squared, then that's minus 8t plus 15 with respect to time. Yeah, that's what we are differentiating. So now when we differentiate, the power becomes 3, and 3 divides the whole term, minus t becomes power 2, and the new power divides everything, making this one a 4 instead of 8. Then plus 15, t is introduced, a constant, arbitrary constant from 3 to 5. Then after this, we can now replace 5 and start with a third, 5 power 3 minus 4, 5 power 2, 5 power 2, then plus 15, 5 plus a constant, like that. Then we subtract when we substitute 3 now. So a third, 3 power 3 minus 4 into 3 squared. Yeah, 3 should be squared. Then plus 15 into 3 plus c. Yeah, plus c, like that. Then now you enter into your calculator and you carry out something called substitution. So in the first case, I'm getting 50 over 3 minus 18 plus c. In this case, the c's shall cancel and we get negative 1 1/3, meaning that now the distance covered is the absolute value, 1 1/3 meters. So that's how you're supposed to work out such a very good question. Thank you so much for following throughout the paper. Thank you. Thank you for finding your time to partner with us. Wishing you success, all the best in the upcoming examinations. Subscribe and share. Invite friends to our broadcast. Thank you.